Hello guys, and welcome to our third video in our basic electronics tutorial. So, on the last video we covered a little bit about using resistors with LEDs. And now we're going to go into a little bit more depth about resistors. You're going to learn about something called a potentiometer, and also voltage dividers. And I'm going to be going between my computer, showing you some and we're also going to learn about the resistor color code. So I'm going to be going between my computer and showing you some basics of resistors by drawing them. And then I'll go back to my breadboard and show you some real life examples. So what we're going to learn to build at the end is just a really basic circuit. Let me show you what it does. It dims this LED with this potentiometer. So I'll show you how it turns. And watch the LED right there as it, watch the LED right here as it turns. So you can see it gets dimmer. It goes up. So let me bring you a little bit closer to you. So it's like right there. This is at full power right now, so if I dim it down, it's lower and lower. So it's back up. So that's where we're going to build the end. It's pretty fun basic design. And now we're going to go to our computer, and I'm going to give you some of the theory and information on this. Hey guys, so today we're going to be learning about series and parallel circuits, voltage dividers, resistors, and as well as potentiometers. So let's get started. So there's two types of circuits you'll find in electronics, and there's series circuits and there's parallel circuits. And the difference between series and parallel is that in series, the current or the electricity can only flow one way, while in parallel circuits it can flow multiple ways. And in series circuits, voltage drops across each resistance, but current is always the same. And in parallel circuits, voltage is always at constant no matter what, but current drops. So if you don't understand that, I'm going to show you in the next, there's a picture on the next slide I'm going to show you. And for resistors, series are always used for resistors because that's the way they're most effective. And in parallel, LEDs are used because they require voltage, and you need the voltage to be constant, not the voltage dropping across LEDs. So here's a series versus parallel circuit. The circuit on the left is a series circuit, and the circuit on the right is a parallel circuit. And as you can see in the series circuit, the electricity can only flow one way because it has to go through the light bulb, out the light bulb, and to the next light bulb, and then to ground. But on the parallel circuit, which is on the right, the current can flow multiple ways. It can go through the first light bulb, or it can keep going along the wires to the next light bulb. But in the other one, it has to go through the first light bulb in order to get to the second light bulb. So there's only one way. But in the parallel circuit on the right, it can either go through the first light bulb, or it can keep going along the wires to the next light bulb. And that are some really basic series and parallel circuits. And as we remember, the voltage is the same. So let's say the battery is giving out 3 volts. Anywhere along this entire circuit, it's always going to be 3 volts. But the current is going to be different. Like let's say there's on the parallel circuit on the right, let's say there's like 100 milliamps at the very beginning of the circuit, and the first light bulb uses 50 milliamps. That means at the second light bulb, there's only going to be 50 milliamps left. But the voltage is always going to be 3 volts anywhere in the entire circuit, no matter what. But in the series circuit on the left, if it's giving out 3 volts and the first light bulb uses 1.5 volts, then when you get to the next light bulb, there'll only be 1.5 volts left because but current will always be the same in the series one on the right. So there's a difference between series and parallel circuits, and now let's move on. So this is some basics of the resistor color code. I'm not going to explain this right now. I'll explain it a little bit, but you can reference back to this and study it yourself. It's pretty standard. Let me show you how it works. So on a resistor, there's color bands. If you have one around, you take a look at it. And on you hold the band up so that you hold it up and you look at the first band. And if the first band is not the one that's gold or silver. It's the one that's any other color than that. So that's that's categorized as the first band. The silver band or the silver, gray, or gold band, that's the last band. To start with the colored band, not the gold band. So the gold band at the very beginning of the resistor, or the colored band at the very beginning of the resistor, signifies the first band. So read what that is. Let's say it was I'm holding a 1K resistor right here. So let's read that. So the first band on this is brown. So as we'll see on this, brown is categorized as 1. So we make a 1 for our first digit. Then we look at the second one, and it's black for me. So that would be 0. So now we have 1, 0. And then the next one is red. So the third band would be, or the third band for me, it's black. Or never mind, no, sorry about that. So for me, it's red. So then I would multiply, so it's red for me, my last band. So I have, my first band was brown, which is 1, then I have 0 for black, and then I multiply it. I don't have a third band on mine, so I go straight to the multiplier. And I'd multiply it by 100. So 10 times 100, that is 1,000. So that means it's 1,000 ohms resistor, or 1K. And then the gold band on the right, for me it's gold, for you it might be silver or maybe even a different color. But what it signifies is how close it is to that value. So that means this resistor is within 5% of 1,000 ohms. So that means it could be a little less, like maybe 9,800 ohms, or maybe like 1,020 ohms, a little bit over. But they're letting you know like how close it is to it. So that's how you read a resistor. You should practice it yourself. The more practice more used to it you'll get. So let's move on to our next slide. So next thing we're going to be discussing is potentiometers. So potentiometers are variable resistors, and the one I have is 0 to 10K, and it works by turning the knob over a carbon film strip, and that changes the resistance. And as we learned before, we have normal resistors, which are always the same resistance, like that one I showed you before, which is 1K resistor I was doing on the slide before, and that's always going to be 1K, no matter what. But with potentiometers, it varies the resistance based on turning a knob. And the most common use for them is volume knobs in your car. You'll definitely have a variable resistor they use to control the volume, and it gives more power to a speaker or less power, so the speaker isn't as loud. So that's one of the really basic uses. So next we're going to move on to voltage dividers. And I'm going to show you a potentiometer on the breadboard after this. So voltage dividers is a way of dividing the voltage. So let's say you had 3 volts and you wanted to get it to 1.5 volts. A really easy way to do that is to use 2 resistors of the same value. So as we learned, this is a schematic right now. This is a symbol for a resistor. This is a symbol for another resistor. So these are the plus and minus, where the little arrows are pointing above input voltage and below input voltage. Those are the positive and negative rails. So we have a resistor, then a wire coming out of the middle, and then another resistor. And it's a voltage divider because it divides the voltage. In the middle between resistor R1 and R2, there's a new potential energy, or in other words, a new voltage, because it as the current flows down, it gets jammed up in the next resistor, so it creates a new voltage, and that voltage comes out of the wire that's sticking out in between R1 and R2. And then the other wire is hooked up to ground, so that would be a voltage divider. We're going to cover that a little bit more in another video. So thank you for watching. Now we're going to move on to the breadboard. Hi guys, and we're back. So this is the final part of the video, and I'm just going to show you a cool circuit we're going to be using that involves some of the stuff we just learned in the presentation. So it's going to be a very simple circuit. It's what I showed you in the very beginning of this video. We're going to be using a potentiometer to dim and brighten an LED. Kind of like how we did with the resistors in the previous video. However, we're going to be using it with the potentiometer this time, which is a variable resistor, as we learned. So the first thing we're going to do, or let me just tell you what you're going to need. So you're going to need a potentiometer. This is a 10K potentiometer, which means it can resist up to 10K. A LED, I chose a green one. Some standard breadboard jumper wires, and you're also going to need a resistor for the LED. If you're using 3-volt power supply, a good value would be anywhere between 50 and 100 ohms. I'm actually going to be using a 100 ohm resistor for mine. So let's set this up. So the first thing you're going to do is we have our power and ground rails on the breadboard right here. We're going to stick the potentiometer into 3 holes on the breadboard. And we're going to use our tapeworm jumpers and connect the ground to one of the outer pin on the potentiometer. Let me move this back. It actually doesn't matter which side you do, as long as it's one of the outer connectors. So we have our power and ground going in there, and the new voltage that comes based on a resistance is going to be coming out of the middle. So now we're going to connect the wire to the middle, because that has to be our new voltage that we're going to power the LED with. We're going to connect that to a new rail on the breadboard. I'm going to do one just right here. That's what it looks like. And now we're going to get our green LED hook it into a new rail on the breadboard, and then we're going to take our resistor, hook that from the wire we connected to the out of the potentiometer, the middle pin of the potentiometer, and connect that to the positive leg of the LED, and then the other leg, which is the shorter one, we're going to connect that to ground with a jumper wire. So go like this, connect that to ground, negative. So here, just a second. So now we can turn the knob. And the LED should light up, as you can see there. As we dim it, it gets lower and lower. Here, let me hold it from above so you get a little better view. So, we turn the potentiometer. LED starts to get brighter. Brighter, and there we go, full brightness and back down. This is just a cool project, really easy with a potentiometer. And we hope you learned a lot in this video. In next video, we're going to cover a new topic called Ohm's Law. And that's a law by a famous electrical engineer. And it's very important when calculating the resistor values. So that's how I'm going to show you how I know what is a good resistor value when I use my LEDs. Thank you for watching, and have a great day.